Okay. All right, so we have this idea of something called a makefile. Does anybody know what a makefile is? As we start transitioning towards actually writing code. Something that makes a file. All right. I guess technically that is true. Can you tell me any more?
Is it a part of that big struct?
No. Makefiles deal with compiling. So actually, tell me about this then. If we are compiling, and this is kind of related to something I said a couple of classes ago when we were talking about compiling like the whole Linux kernel, something like that. So we're going to say if we're compiling a lot of source code files, and something goes wrong halfway through, it might be nice to be able to pick up where we left off in order to finish compiling after we fix an error. I had mentioned that if you're compiling the Linux kernel, for example, it might take, even on today's machines, it might take, 5, 7, 10 minutes or something like that. I haven't compiled it in a while, so I'm just kind of making a guess. It'll be substantially longer than instantaneous, okay? Because it's compiling a lot of individual files. Now, when so there's a program called Make that follows the format of a make file, which has a specific syntax that we'll look at here in a few minutes. We'll look at a Makefile tutorial that kind of shows us a simple one. All right. So what you do is the Makefile has different directives. You could think of these as like variable names. Now, common directives might be something like make clean or make install. So make clean typically would remove all current compiled files, potentially in preparation to compile from scratch. Let's say you happen to have made some substantial changes or something like that, and now you are going to make again, and even though you had spent some time getting halfway through compiling all the files, now some of those things that have previously been compiled no longer apply because you've made some changes. Now, what I mean by that is with a Makefile, the time that you would go through and you would compile this big project and you get an error somewhere in the middle. that's when you would like that Makefile to help you maybe say, oh, I had this little bug in this one file. You go and make a fix to it. Then you just pick up where you left off. That would be nice. But there might be plenty of times where maybe there's 10 files and you've done a make, and maybe the make completed successfully. Or maybe it got to file number 8 before it had the error. Well, if you went back and had to make changes to file number 1 or 2, even though they successfully compiled the first time around, you would then have to recompile. Just like in real life, if we make a change to a file that's already been compiled, we have to compile it again, because the output of those compile files would have already been in the directory, and a make would just pick up where it left off. So if there's a situation like that and you want to force it to restart, you would do a make clean first, which says remove all the object files. Anything you've compiled before, let's forget about that. We're going to do this from scratch. I've made too many changes, something like that. Okay, make install typically does a full compile and then copies the binaries to the appropriate directories, maybe /bin or /user, local bin. These are kind of common Linux directories. Typically /bin would be where your like operating system binaries would be. So user local bin might be where your personal, like I've compiled something, I've installed a local program. Think of that maybe like C:\program files on Windows, something along those lines. But if you're a super user, you can put the stuff wherever you want. All right, so make install might do that. Maybe a make uninstall typically will remove the binaries that have been put into the OS. This is no different than like on Windows. If you uninstall a program, the expectation is it's gone through and it's kind of removed the executable from the programs folder. But maybe also if you have something that maybe there's an application that starts up when the computer starts, maybe it goes in and removes it from the startup folder too. You expect that an uninstall removes all occurrences, all traces of the application, right? All right, so this is kind of the Linux version of this. So we can think of a Makefile as a precursor to like an installer, and it's not as friendly. All right, it's not as friendly, but once you get used to using it, I mean, the real example is so if we take the folks that are in this class, I'm guessing that many of you at least have never actually created a setup installer on Windows, right? There's programs that let you do it that effectively generate something that is like a competitor with a Makefile, right? Except a lot of times the stuff's already compiled and things like that. But generally, when you get a new piece of software, you download off the internet or something like that, somewhere in the folder, there's like a thing that says setup. You double click the setup thing and it launches into this GUI install stuff thing, where a Makefile is all done at the command line. Let's see, we got a chat. Oh, I saw that one earlier. Okay, so do we generally understand kind of the high level of what a Makefile is for? All right, so I was looking at a simple tutorial earlier. Let's see if I can find it quickly on here. And we're just going to kind of go through the motions, creating those couple of files to compile and stuff that's very simple. We can copy and paste it. Let's see, is this the one I liked? I think this is the one I liked. Can I read this now? Can we all read this? All right, so the first thing we're going to do, we're actually going to do this with C++, but that's okay. It just, the tutorial makes it nice and easy to copy some files. All right, so we're going to create, notice here we have 4 different files here. We have a couple of C++ files. We're giving a lot of stuff here. How about you ask me later? There we go. So we have 4 different files, a header file and a couple of 3 CPP files. So we're going to go ahead and just create a directory and put these files in there. All right. And I'm going to do this through Visual Studio Code. Let's see. So I'll go in here. I'm going to create a new folder. We're going to call this guy, actually, didn't I already do a CSC450 folder? Yeah. And I'm going to put a folder in there. We're going to call this guy Makefile tutorial. All right. And then what's the name of our first file we're putting in there? This is main CPP. Just copy this. All right, so there's main CPP. It's screaming about this functions.h thing because I haven't put that file in there yet. So just roll with it for right now. Then I'll go ahead and get hello CPP. All right, so there's my hello CPP. Then we're going to get factorial CPP. And then lastly, my header file. And this is functions.h. I need to take this shield through a car wash, I think. It's like dust and stuff on the inside of it. Functions.h. All right, so these are just the prototypes for those functions. I'm not going to go into it too much right now. We want to focus on the Makefile part of this anyways, and we're going to be doing mostly C in here, so I won't spend C++ time. This just gives us a quick example. Okay, now if I wanted to compile this, I would have to give it all of the CPP files all in one line. I would call upon GCC, the GNU compiler collection, and feed it these 3 input files. It would look at the MIME type on them and see CPP and use the C++ compiler for this, which is G++. And then rather than the defaults of what you've seen before is usually when you compile C++ files, it gives you that a.out file. That's like the default executable. You can overwrite that and do a -o for your output file and say, maybe it's hello. It's the name of your executable. Okay. So I'll just copy this line real quick. We'll go out here. If they could hear that online, or if they, like, what is Lippman doing again? I mean, it was funny for like 30 seconds and then just kept going. It was like an hour. What am I looking at here? Oh, this is, I think this is from last year. Is it in download? Let me just see where this is stored. Oh, it's inside of CSC450 for, let's just say, no good reason, but It's just how I function. There we go. All right. Where did I put the rest of the files? Didn't I have like multiple files in there? Where did I save the other guys? Hold on. All right, so this one needs to get inside of that folder. Sure you want to move. Yes, move that. You have a main, hello, factor. Where's my factorial? Functions. How did it get all the way down there? Yeah, are they all in there now? Functions.h. That's what I'm looking for. Oh, here it is. Just go into this folder. Oh, I don't think so. There we go. All right, so now I have 4 files in the same folder. Hercules. Ay, ay, ay. So now we'll go ahead and we're going to old school compile this, right? So we'll do our GCC, give it all the input files and say, this is what our output file is. So this is kind of what you would have done before maybe having a Makefile. And realistically, for such a small project like this, compiling 3 files in the command line like this isn't like the end of the world, right? Control V, there we go. If you're ever trying to paste at the Ubuntu command line, it's Shift Control V for pasting, not just Control V. Or you can probably just hit Edit. All right, but we'll go ahead and compile that. Let me see if that'll clear up if I just use G++. All right, so there's why I use G++ instead of GCC. I mentioned a few minutes ago, GCC was going to pick up the .cpp and know that the MIME type for that was C++, so use G++, but it didn't. So I just replaced the GCC part with G++ to compile. So there's my output file, hello. And there's hello world, the factorial of 5 is 120. We have a working program, okay? Now, what if we wanted life to be better, let's say, with a Makefile? All right, so make program allows us to use macros, which are similar to variables, like I mentioned before. So macros are defined in a Makefile as a bunch of name value pairs. So we can say, hey, here's some stuff that I might want to interject during the command line in there, and I'm going to make a placeholder here so I can use it throughout. All right. So it might have like the C flag. So a lot of times when you're compiling a program, you might be able to give it some command line flags to GCC for like how you want it to, like maybe what architecture you're targeting. For example, the default would be the architecture that the operating system's running on, but you certainly could use GCC or G++ to compile for a MIPS architecture, something like that, even though I'm running on top of Intel here. I wouldn't be able to run the program on this computer, but I could compile it for a different architecture if that architecture was supported by GCC. I probably could go out and find a MIPS emulator so that I could compile for the MIPS architecture, then test it on a MIPS emulator. All right, but all we need to really think about right here is that you might want to have like a place where you can give it some flags, and you might want to use C flags all over the place inside your Makefile. Maybe every single time you compile a file, you want to use that same collection of C flags. You would define the variable once with all the stuff in it, and then anytime you were going to use it, you put C flags in there as a placeholder. And if you decided, oh, I need to add another flag, you can add it just to one place, and then it's true everywhere else. Okay, so these are just variables, name value pairs that are up here inside of a. All right, and then you can see how they're used inside of a Makefile. You put a little $ before it. So this says, you know, whatever C flags is, go ahead and replace this with the value found inside of C flags. All right, so I'm actually just going to get down to the actual example thing here. So we're going to put this inside of a file called Makefile. I think it's got to be capital M with the rest lowercase. Let's see if they just give us the whole file as one thing on the next page. Just give me the Makefile. All right, I'm just going to do this. Simple Makefile. We'll still use those same files we were just doing. Make build. No, that's really not any better. We'll do it their step-by-step thing then. So I want us to have a model after we're done with this. All right, so we have those done. Now we're going to go create our Makefile. So I'm going to create another file in here, and I'm almost positive it is Makefile with a capital M. So we can always rename it. Because the make command, and look, it looks like it recognized it as that type of file. The make command will automatically look in the current directory for the make file. All right, so here's our Makefile, and we're going to put some stuff in there. We'll just going to copy and paste their stuff just to get a basic starting point. So we just have some name value pairs there at the top. All right, now here are our compiling directives. So if I just do make, what it's going to do here is it's going to produce an executable called hello that is going to come as a result of compiling main CPP, hello CPP, factorial CPP. The compiler I'm going to use. So something it mentioned in the previous page, I didn't read all the text to you, but there is already a global variable called CC. And let me show that to you. So I come out here and I say echo $CC. Isn't it that? Just echo CC. Let's look at the environment. Oh, is there no CC? So there's global environment, global variables and available in any operating system environment. It exists in Windows as well. It exists in here. I'll just bring out a couple of highlights as we're looking at this, because one of them is going to be the path. So the path environment variable, this guy already exists. These are all the places that when I type in a command, if I type in GCC, for instance, and I press enter, it's going to check all of these different locations as a possible location for that executable. All right, this is unrelated to Makefiles. This is just an operating system thing. Same thing's true on Windows. Okay, Windows has a path environment variable that says, look, if you just type something and I'm going to treat that as if it's an executable, and I'm going to look in these 7, 8, 9 places, whatever it is. So if I have a file in this local directory, hello, and I just type in HELLO and press enter, notice it said, hey, I don't know about that command. We can see that it's right there. I can run it if I say /hello, right? / says look in the current directory and run the program called hello. But if I just run it by itself and just say hello like that, it checks all those places we just saw in the path variable, and it didn't find it in any of those places. So I had to give it either the full path or the relative path to where that lived. Okay. So in this Makefile, and this is true for a lot of Linux distributions, there already is a thing called CC, an environment variable called CC, which a lot of times like Linux would be related to the GCC command or just the CC command. CC is the non-open source C compiler. GCC is the open source C compiler collection, technically. All right. So this $& thing, that is the placeholder for the label that we're currently in. All right. So what we're effectively doing is we're saying compile with these flags the names of my files here. That's the $? All those things. And then give me my LD flags, which would be linker flags, which also typically there is a environment variable for those. Let's just see if there was for this. Nope, it's not. And what I'm doing here, when you see me, when I say env, I get this big wall of stuff. If I want to search for something in there, I can, instead of having that output go to the screen, I can pipe that into something else. That's what that vertical bar is. So I'm going to say, instead of it going to the output screen, I want to pipe it into another, could be an application, whatever. So if you want to see, let's say you have something that you do it and it goes like 50 screens. You might want to pipe it into the program called more, which lets you deal with it one line at one screen full at a time. So, we have a username variable there, a user variable, desktop session, whatever. So you got a bunch of things. You can go one screen at a time that way. But if you want to search within it, there's a program called grep that allows you to give it a regular expression of what you're looking for. So I was looking for something called LD in there. That's not the one it was. This is the old password, but regardless. So it seems to be using a couple of environment variables, assuming some environment variables that weren't there. All right, we'll go ahead and run this, and I'm expecting to get some errors, and then we'll go ahead and add them in up here since we didn't create them ourselves. All right, so it's going to presumably use whatever the C compiler is with whatever flags we've given it, which is for this architecture type and stuff like that. I'll actually probably remove that in our example here. And what are we compiling? We're compiling these guys right here with whatever linker flags and we want our output to be hello. All right, so I'll go ahead and save this. We're going to go back out here. I'm going to remove the hello program, so it's as if we haven't compiled at this point. And of course, I don't have a Makefile there because I'm incompetent and I can't land stuff in the right directory clearly. Why? You can do it. It's really bad. All right, so if I type in make, let's see, Makefile missing separator, line 9. I'm guessing it's because it's complaining about one of these things. I mean, I could hard code the stuff in here, so I can say G++, ooh, hello. I can take C flags out. I can take this out. We'll just do it like that for right now. Nine. What is it not liking? I'm going to take that out for a second. They pay very close attention to the formatting, so I must have an extra space somewhere or something. Yeah, because I cut and pasted. Well, I didn't actually cut and paste, did I? Well, I did with tabs. So I'm guessing it's that guy. Just click the space 4 at the bottom right corner and change it to tab when editing your Makefile. Okay. Guessing that will just do it. Looks like it has to be exactly 4 spaces. Huh? Down right corner. Oh, space 4. I see space 3. Remember I said earlier it's not as friendly? Just give me the right tabs. Might even be from a previous line. Do I have extra spaces somewhere? What if I just put it left justified? It's got to be somewhere else in the program. My format's correct, isn't it? So it looks like it wanted it down on a different line. GCC. Maybe he made a GCC one. Okay, so it's pretty similar to what we're trying to do here. I'll just loop his in. We don't need any C flags. These are the inputs. Actually, he actually hard-coded them in. We'll do that too. So those are our input files. Our output will be hello. Let's start with this. Let's see if we can get it working. Make is the name of it. Shouldn't have to. Yeah, because this is what we want our output file to be. This is just the label. I mean, we can call this LOL if we want. Because you might have like a LOL, you might have a clean, you might have an install, you have different directives you can give it. And then this is what you want to do for each of those directives. We'll actually change this to G++. We saw that already before. This is the directive. What doesn't it like? This is definitely the one that looks the yeah, we're doing it right. Well, clearly not, but it appears like we're doing this right. Down here?
Yeah.
Wait, left click it?
No, and then edit a new like little window.
I have a new little window. Is this what you're talking about?
No, it was like up towards the middle top of the screen. And then index tabs.
Oh, I see what you're saying. And now it says tab size. Okay, good. Now we got a better, thank you. All right, so I did make, it went ahead and it did the G++ dash O hello. And we see we got our hello output there. If we go back into the Makefile, I think we should have been able to say make LOL actually. So since we only had one thing in there, there was the default LOL. I think you can also just say default, and that'll turn into, so if you do two separate things, it'll do that. But anyways, we might want to put in our different files here. So maybe we have our source files. And our source files might be this. These guys. And we might have our output file. Or maybe we have our exe. And we want this guy to be called hello. So we'd have $ source files. And $exe like that. I think you just do make default like that. Now, if we put in here clean, what we might do is we might say rm exe like that. So we have a couple of different directives now. So that's what it looks like right now. If I do make clean, it got rid of that header file. So that if I do make, it compiled it. Make sense? And then a lot of times you might have like a make install in there. We're just kind of finishing out this thing. You might have install where maybe it's move ./bin or something like that. So I'll fake it. So I'll do a make dir bin in here. So we'll do a make clean. We'll do a make, and then we'll do a make install. And now inside of our bin folder is our hello program. So that would be kind of the idea, is you build your own little executable or your setup program, if you will, and it lets you do the whole rigmarole. If you want multiple things to happen from one, you can do a compile and install at the same time, and sometimes even make install will be set up where it calls one of the previous things. Like if you didn't compile, call this guy, that type of thing. Yeah, mostly it is streamlined, but it's mostly managed. So as you keep adding crap to your program, you would just go up to the top here and, add more things to your source files, maybe, and you can imagine this might get more and more complex, right? So this is a way of not losing track of what worked before and being able to make small adjustments and compile it again, that type of thing. All right, and then maybe you do a make uninstall. Actually, maybe make clean would actually do this. So make clean might remove ./bin, but actually what you might say is you might say install dir is equal to ./bin. Like that. So if I do a make install, and we see it in there, make clean, removed it. See nothing in there now. gives you management tools for doing that stuff. All right, that makes some sense. All right, so what I'll have you do, since everybody should have a form of Linux or something now, and remember, if you use Visual Studio Code, if you use VI, you shouldn't have a problem. Tab should be a tab. But if you use Visual Studio Code, well, what I had read said to do something, but I wasn't smart enough to understand it. So he helped me. He translated it to human for me, I guess. So you click on the tab size thing at the bottom or whatever it used to say, and then you can, or maybe it says what, space, I think it said spaces 3 before. You change it to tab because Makefiles are very specific about their file formatting. Okay. So I'll put up a link to this tutorial. What I'll have you do is, it'll be an assignment. So I'll put up the assignment. It'll have you go through this little tutorial for the Makefile, effectively what we did identical in class today. All right, get this working and I'll have you submit a screenshot kind of showing, hey, I got it to compile or whatever. So then we'll know that you have a functioning G++ compiler and stuff like that. So we can compile our first driver, hopefully next class. Sound good? Questions, comments, concerns, bribes? All right, I will see everybody on Wednesday. There probably is, Noah. If not, there probably is a tool online or something like that for generating Makefiles. Generally, I like doing things by hand, at least at first, so you kind of appreciate what it's doing, but Makefiles have been around for a very, very long time. Hence the reason they're pretty particular about stupid things, spacing and that kind of stuff. But to your point, I'm sure there's an app or a website or something where you can just fill out your pieces of information and it'll just generate a Makefile for you in the right format. And you copy and paste it in and move on with life.